So this is page 2 of our day 4 notes. In example 4, we have a fair coin that is flipped and a fair 6-sided die that is tossed. The probability that the coin lands on heads and the die rolls a 6 is going to be an intersection of those two events. So let's start by finding the individual probabilities. The probability of heads is 1 out of 2, and the probability of a 6 is 1 out of 6. And the probability that both happen is going to be their product, 1/2 times 1/6. So now we want to find the probability that the coin lands on heads or the die rolls a 6. So that would be the probability of heads or 6, and it's going to equal the probability of the heads, which is 1/2, plus the probability of a 6, which is 1/6, minus the intersection. And with a common denominator, you should get 6/12 plus 2/12 minus 1/12 equals 7/12. In example 5, we have events A and B, who are independent events, such that the probability of B is 3 times the probability of A, and the probability of A and B both happening is 0.68. So we're going to start with our formula. The probability of A, UB, is equal to the probability of A plus the probability of B minus the intersection probability of A intersect B. And we know the probability of the union is 0.68, and probability of B is 3 times probability of A. So I'm going to write probability of A, and I'm going to substitute for B 3 times the probability of A. And then the intersection would be the probability of A times the probability of B. So I'm going to have the probability of A, and instead of writing times the probability of B, I'm going to substitute again 3 times the probability of A. So now I have an equation that is looking quadratic in nature. So I'm going to do a substitution so that this is easier to deal with. I'm going to say let x equal the probability of A. And so now I have 0.68 equals, I have probability of A and 3 probability of A. That makes 4 times the probability of A, which is 4x. Minus, this is x and this is 3x, so that will be 3x squared. So move everything to the same side and set it equal to 0. So I have 3x squared minus 4x plus 0.68 equals 0. And I'm going to use the quadratic formula here. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, and I'm going to pull up the calculator. And I've entered that in the calculator. So I started by entering the plus, and I get a probability of 1.13, and that just doesn't make sense. Your probability can't be more than 100%. So I'm just going to change the plus to a minus. Oops, that's not what I wanted to change. Try again. 4 minus, and I get this time probability of A, which was my x, is equal to 0.2. So let's go back. So I get x is equal to 0.2. That's the probability of A. And the question's asking the probability of B, which is 3 times the probability of A. So the probability of B is going to be 0.6. All right, last we have an IB problem with a tree diagram. We have the probability of R is 1/3, the probability of S given R is 4/5, and the probability of S given not R is 1/4. So in the first event, you can have R or not R. And since those probabilities have to add up to 1, if this one's 1/3, I know this one's 2/3. Then if R happens, you can have either S or not S. And they told us that S given R is 4/5. So that's this one here. This is S given that R has happened. And since these two events have to add up to 1, that makes this one 1/5. And they tell us S given not R is 1/4. That's right here. And so we know that this one right here has to be 3/4. Okay, now we want the probability of the intersection of R and S. So that's going to be probability of R, which was 1/3, times the probability of S given R, which is 4/5. And that gives us 4/15. The probability of S is going to be the sum of the two events where S happens. So that would be R happens and S happens, and not R happens and S happens. So the first one is going to be 1/3 from here times 4/5 here. And then the second one is going to be 2/3 times 1/4. So we get 4/15 plus 1/6, which simplifies to be, let's see, over 30, be 8/30 plus 5/30, so 13/30. Okay, and the last one is the probability of R given S. So we're going to set that equal to the probability of the intersection of R and S over the probability of S from our formula. And the probability of R given S is 4/15. That came from up here. The probability of S we found was 13/30, which simplifies to 8/13. And that's it for the notes. Make sure you have also done the Monty Hall simulation and that you do the homework problems.